All right, so at the top of your paper, go ahead and put Trig Proofs. You do need your green sheet out. We're going to refer to it. All right, so this is similar to what we did yesterday. It's a little bit different. I'm just going to go ahead and go through some examples, and I'll give you some strategies as we go. We're going to do secant x minus cos x equals sine x tan x. So this time we have two sides to an equation. We don't just have an expression. And the goal of these problems is to show that one side equals the other side. So we're going to manipulate one side of the equation to make it become the other side. So one rule that you have to remember is that you can only mess with one side. You can't change something about the left side, then change something about the right side, then change something about the left side. You can only do one side at a time. Okay? The other thing we want to keep in mind is that when we work with a side, when we choose a side, we want to choose the side that is more difficult. It is a lot easier to take something that's difficult and simplify it than it is to take something that's simple and make it more complex. Okay? So I'm going to call the left side the complex side because it has two terms, something minus something. I'm going to call this the simple side because sine times tan is one term. Okay? It's going to be easier for me to take these two terms and mush them together to make them one term than it's going to be for me to take these and split them apart. All right? So we're going to take secant and we're going to take cos, and we're keeping in mind that while we do this problem, this is our goal. Okay? So what on the green sheet do you think you could use? 1 over cos minus cos, right? Okay? I keep this the same. I never get to touch it. The sine x tan x is going to stay the same throughout the entire problem. Okay? Yep. Okay. I have a fraction minus something that's not a fraction. Make it a fraction. I'm going to put it over 1. And what do I do to subtract two fractions from each other? Common denominator, which would be cos. So I'm going to multiply by cos on the top, and I'm going to multiply by cos on the bottom. So now I have a common denominator of cos. And what do I have on top? So for the left fraction, we've got 1 minus cos squared. Okay. Okay. So what does our green sheet have? Yeah, the Pythagorean identity would work. So 1 minus cos squared is sine squared. So I have sine squared x over cos. And I need it to equal sine x times tan x. Sine over cos is tan.
And then there's still one more sine.
And then there's still one more sine. So what I'm going to do is I'm going to split the top as sine times sine over cos. And then I can see that sine over cos is tangent. And so we have tangent times sine. You guys see it? So this part right here is tan. Tan times sine. Okay? So I'm going to say, and I'll go ahead and write it the same order that they had it. So sine x tan x equals sine x tan x. Check. I'm done. And if you notice, the right side stayed exactly the same the whole time. I didn't do anything to it. You want to show that the two sides are the same. So when we do it, we pick one side to work with and we stay with that side. And we always pick the more complicated side because it's easier to simplify something than it is to make it more complicated. Okay? All right, so let's try another one. So 1 minus sine theta over cos theta equals cos theta over 1 minus sine theta.
1 minus?
Or 1 plus. Sorry, 1 plus sine theta. Okay. Can we cross multiply? No. Why not? Yeah, one side has to stay the same. All right. Now, on this problem, does one side look more complicated than the other? Not really. They look about the same, right? They're very similar. So in a case like this, you can work with the left side or the right side. It's not going to make much difference. The process will be essentially the same no matter which side you use. So which side do you guys want to use? The left?
Yeah.
Okay. So whenever you see problems like this is a strategy that doesn't work always, but it works sometimes. Okay? Any strategy I tell you, you can't get mad if it doesn't work because none of the strategies work 100% of the time. Okay? So one of the strategies is called multiplying by a conjugate. Does anyone remember what a conjugate is?
Yeah.
You take the same thing, but you change the sign in the middle. So 1 minus sign and 1 plus sign, those are conjugates of each other. All right, because they're opposite signs in the middle. So, and that's the way to do this particular problem. Does it always work? No. Does it work sometimes? Yes. So it's a strategy that we're going to save and maybe use. Okay? So I'm going to take the left side and I'm going to write 1 minus sine theta times 1 plus sine theta. And then on the bottom, I have cos theta times 1 plus sine theta. So what I did is I took the original problem and I multiplied by the conjugate on the top and the bottom. Okay? I didn't cross multiply. I'm keeping the problem on the right the exact same. So I multiplied by the conjugate on the top and the bottom. Okay. What happens if we FOIL the top? We have 1 plus sine minus sine minus sine squared. So I'm going to go ahead and write that. I'm FOILing it. 1 times 1 is 1. 1 times sine is positive sine. Negative sine times 1 is negative sine. Negative sine times sine, negative sine squared. Okay. And for just right now, I'm going to have you guys leave the bottom the same. I'm not going to have you distribute. Now, one of the reasons I would know that I should not distribute on the bottom is because I can see that the final answer should have that on the bottom. Does that make sense? Okay, so I know if I was to distribute the cos, I would just have to take it right back out again because the final answer should have this in it. Okay, so you can definitely, as you're doing the problem, if you want to check over and make sure the right side of your problem is still like getting closer, then that's a good way to kind of check as you go. So it really is kind of like you have the answer key right beside you and you're cheating a little bit each step. Okay, what do we see with the top? The signs cancel, right? So we are left with 1 minus sine squared. We are left with 1 minus sine squared, which is cos squared. Okay, so I'm going to say cos squared 1 minus sine squared is cos squared. It's one of the Pythagorean identities.
Oh, geez.
Is cos times 1 plus sine theta. And then what happens? Yeah, you can cancel a cos. 1 cos on the top can cancel with 1 cos on the bottom. And what do you see now? You are done. Okay, example 3. If we have cosecant theta times tan theta equals secant theta, which side is more complicated? The left. Do you always work with the left? No, you work with the more complicated side. Us working on the left 3 times in a row is a coincidence. It does not mean you always do the left side. Okay? All right, this is going to feel a little bit more like a problem that we did yesterday, where it was just like, hey, simplify this. And then you could flip the paper over and be like, oh, the answer is secant. That's what I have to get to. All right, because this is a pretty simple problem. So what should we do with the left side to fix it? Substitute. So 1 over sine times sine over cos. And I have to leave secant theta just like that. Sines cancel. So we have 1 over cos is secant. And 1 over cos is secant. And so secant equals secant. So that one was really simple, right? Yeah, they're not always really simple, but that one was really simple. Okay. All right. One last example before I let you guys practice on your own. We're going to do 1 plus tan x over 1 plus cotangent x equals tan x. I should have written it backwards just so that we'd have to do one on the right side. All right, which side is more complicated? Like definitely the left side. Definitely the left side, right? So one of the things that I said yesterday when we were doing simplifying is I said when you see a direct relationship with the problem, don't necessarily put it in terms of sine and cosine, right? So a lot of students would look at this problem and be like, let me turn it into sine and cosine. Sine and cosine is a possible way to do it, but you add yourself like 5 to 7 extra steps. So this problem is easiest to do either in terms of cotangent or in terms of tangent, because cotangent and tangent have a direct relationship to each other already, okay? Now, if the right side says tangent, then which should we convert it into? Tangent, okay? So I'm going to leave the top part the same, because it's already written as a tangent. And then on the bottom, I'm going to rewrite it as 1 plus, and what should I replace it with? Should I do sine, or should I do cos over sine? I'm going to do 1 over tan. So the reason I'm doing 1 over tan is I just want the whole thing to be in terms of tangent, since the right side is only tangent. Okay. All right, on the bottom I have 1 plus a fraction. Common denominator. So how can I rewrite the 1 so that it has that common denominator? Yeah, I'm just going to call it tan over tan. Have you noticed that we've done that more than once now? Taking a 1 and turning it into something over something. That, I would say, is a strategy that I use often. Anytime I've got a 1 in a problem, I just make it the same thing as the common denominator and just make it that over itself. Pretty common. All right, so I'm going to write this out. I have 1 plus tan x. And then on the bottom of the fraction, I have a common denominator of tan x. And what is on top? Tan x plus 1. So there's the top of my fraction. Here's the bottom of my fraction. Overall, that equals tan x. Okay. And then what do I do? Yeah. Keep, change, flip. So keep the top the same. Change it to a multiplication problem. Flip the bottom up. And so this part on the bottom and this part on the top can cancel. It's okay that they have a plus sign because I'm canceling the entire thing. I'm not saying 1 and 1 cancel. I'm not saying that. I'm not saying tan and tan cancel. I'm saying the whole thing. 1 plus tan x is the exact same as tan x plus 1. So this whole thing cancels with that whole thing. And we get tan x equals tan x. So we're done. Okay. We have a couple strategies to add to our strategy sheet. So I don't know if you want to put all of your strategies on yesterday's notes, because we have listed a bunch of strategies yesterday, or if you want to write new strategies today on these notes. But we're going to go ahead and add a few strategies, so you can put it wherever you feel like putting it. So one strategy that we talked about specifically with proofs is that you work with the complicated side. It would have been really hard to take tangent right here. It would have been really hard to take this tangent and turn it into that left side, right? That would have been very difficult to do. It was a lot easier to take something on the left and make it more simple. Okay, so always work with the complicated side. Another strategy we talked about was multiplying by a conjugate. So we saw 1 plus sine theta. Actually, we had a minus. So we multiplied by 1 plus sine theta. And that could work out the same for something that said 1 plus tangent theta. It could work out the same for cos theta minus 1. But if you notice in the recent example that we did, we had a 1 plus tan x, and 1 plus tan x has a conjugate, and we did not use it. So using a conjugate happens sometimes, but it doesn't work every time.
How do you know if it doesn't work?
You almost will get a sixth sense for when it will work, like once you've done enough problems. For instance, when I looked at this, I was like, tangent and cotangent already have a direct relationship with each other. If I multiply by 1 minus tangent, I'm going to get 1 minus tan squared, which turns the problem into secants. That's not helpful. But that's because I've done a bunch of problems, so I know how it kind of works out when you do that. So the more you do, the more you'll start to recognize when to use what strategy. Okay? Did we talk about any other strategies? I don't remember. Ooh, one to add here is that factoring, you might factor things sometimes. And that seems to be something that students tend to forget. So factoring might be a strategy, taking out a GCF and then letting it cancel with something. Okay. So we'll go ahead and get started practicing. If we run into any other strategies, we can add to our list. If you think you've come up with a strategy and you want to share it with me, then we can share it with the class. If we decide that, like if you're just unsure about it, we can then share it with the class if it's something that everyone would benefit from. Sound good?